67 amps. Oh. I ran into a cellar circuit that faulted out every time I reset its brand new dual function AFCI GFCI circuit breaker. Well, as you can see here, there's been quite a bit of progress moving the circuits over to this new sub panel from the transfer panel over to the sub panel. And for the most part, about 95%, it's been trouble-free. Well, I've had two problems so far. I was determined to use all arc fault ground fault breakers in here, dual function breakers. They're an arc fault interrupter and a ground fault interrupter. And the reason for that is that there's a lot of stuff in this house that I'm just not comfortable with. A lot of the way it was wired, and it's a little old. The purpose of arc fault breakers are to detect problems in the wiring. If there's a little arc, let's just say there's a little split in the wire or a bad connection, there's a little bit of an arc in there, it'll shut the power down on that circuit. So both of my problems were related, I think, to that. Although I haven't figured out this one yet. That's what I'm making this video about. The first one was this one, which is the furnace circuit. Every time the furnace started, it would trip out. So I've convinced myself that this furnace circuit was tripping on arc fault because if you remember my duct booster, I added a relay to control that duct booster motor. So that relay has contacts that open and close. And when those contacts open, there's going to be a little arc between them. I think those arc fault breakers are sensitive enough to recognize the arc signature from the contacts opening, and that's why it shut the breaker down. So I can't run arc fault on the furnace circuit. That's why I ended up putting a standard breaker back in, and it's been running fine ever since. This one, however, where I'm almost done moving all of these, it's not the last circuit, but close to it. There's 3 more to do. But this one here is for the receptacles that run along the cellar here. And this is the only one that instantly, after I got done wiring it, I turned it on and it tripped out. And I reset it, turned it on again, it tripped right out. So I was like, wow, there's a problem with this circuit. So I went down the line here unplugging things from this circuit. There's 7 receptacles on this circuit, and that's one. And that one was recently redone, and I think that one is probably the only one that's sound on the whole circuit now. There's a receptacle down there behind this fence, behind the shelving. It looks like a fence. Behind this shelving that the dehumidifier is plugged into. There's a receptacle right down there that has an extension cord plugged into it that I had a light plugged into, but there's nothing plugged into it right now. There's that receptacle right there, which has nothing plugged into it. Underneath this makeshift workbench sort of thing, there's a receptacle right there, and that has a cord on it that just comes up to a receptacle here. And this is where I plug in this light fixture, which is now off because the circuit is tripped. There's a receptacle there that only had lights on it. Actually, it had lights and this air purifier plugged into it when the problem started. There's a receptacle under the table here on the wall back there. You can see it. And that orange cord was plugged into it, and that's one of our little chest freezers. We can't have the freezers going unplugged. And there's a receptacle down there that this chest freezer here was plugged into. The old reliable. So I went down the line on this receptacle circuit, and one at a time, beginning with the closest to the breaker, going all the way out to the farthest from the breaker, I unplugged the loads from them one at a time and reset the breakers. So I unplugged the dehumidifier first, reset the breaker, and it faulted out immediately. So I figured it's not the dehumidifier. Then I went to the next one, which is the light under the bench, that plug under the bench. Reset it, and it immediately faulted out. Then I went down to the next one, which was that air purifier, unplugged it, reset this, it faulted out immediately. So then I went down the line. The next thing is one of the freezers. I unplugged that, reset this, it faulted out immediately. Now there's only one thing left, and that's the old freezer on the end. So I unplugged that, and there was actually one of those pest repellers plugged in there. And I unplugged those, reset this, and it stayed. It didn't fault out. So now I had no loads on anything, so it kind of makes sense there would be no arcs, but it stayed. So then I plugged the freezer back in on that end, and then the air filter, then the light over the workbench, and then the dehumidifier, each time resetting. Well, it didn't trip. It didn't trip at that point. Nothing tripped it. And we went out for dinner, and when we came back, it was tripped again. So I knew the freezers had no power, and I had to work on it last night. Eventually what I did was I just ran power to the freezers with extension cords from another circuit, and they've been fine. So there's a new receptacle over by the utility sink. I added this when I added the sub panel in the garage, and this is both AFCI and GFCI protected. So I plugged both of the freezers in there on extension cords, and this will not only keep my freezers running overnight, but it'll prove that they're not tripping an AFCI or GFCI circuit. I'm not going to trust this circuit with the freezers until I figure out this problem. Okay, so the next thing I did was I unplugged everything, turned off everything except for the dehumidifier and a light or two downstream. And then I started running some tests on the dehumidifier. And I plugged it in down here with the receptacle I just installed down here in this new wall. And then plugged back into its original place over there by that shelving unit. So now I'll show you the results of that testing. So right now the testing I'm going to do is with the dehumidifier plugged in over here. You can see the receptacle there, conveniently located behind this storage shelf unit. If I have to work on that receptacle, I'm going to have to move that whole unit. That holds all my plumbing supplies. At first I simply watched the circuit breaker to see if it was going to trip, and after about 1 3/4 minutes it did trip. I realized this wasn't telling me much, so I started taking current readings. It's reading about 1.7 amps. It says 1.68, 1.69. So it's got 1.7 amps on it right now. And that's almost all the dehumidifier. And I put the dehumidifier fan on high speed just to try to increase the load. Maybe that'll help it trip out quicker. Interesting. I cranked that dehumidifier up to non-stop and it tripped. So it was trying to restart the compressor and it tripped. Let's try that again. It sounds like it's running. So I adjusted the dehumidifier set point to 50% humidity, so it should shut down the compressor, and then I'll reduce the set point down to like 35 and it should pick up. or I'll reduce it down to continuous run, and it should start back up again. And we'll see if this trips again. And by the way, this humidistat here shows 33% humidity. Oh, it did it again. I changed the set point on the dehumidifier to continuous run, and it tripped. So that tells me just the fan was running when I did that, and when I went to continuous run, the compressor started, and that tripped this. Okay, so I moved the dehumidifier power cord to this extension cord, which is plugged in over to here. Now I'm going to run the same test. That is, changing the set point up and down and see if it causes the breaker to trip. Okay, I adjusted the dehumidifier down to non-stop running and it didn't trip here. So let me wait a while. I'll have to try more than once to see if that really made a difference. Let me see how much current that thing's drawing right now. That's showing 5 amps on the circuit. I have a feeling that means the compressor's running. So if the compressor cycles off here, we'll see the amperage drop, and then I'll try that again. I'll set it to continuous run, and when the compressor starts, we'll see the current come up, or we'll see the breaker trip. Oh, now it's reading 1.67 amps. So now I'll go change that setting. I changed it and it didn't change the draw. Alright, it's set on non-stop run. So that compressor should start at some point soon, and we should see that jump up to 5 amps again, I'm thinking. It's one thing I hate about these Klein meters. is they time out and shut themselves off after 5 minutes. That's a pain when you're trying to monitor something over time. Well, there it went back up again to 5 amps. And it didn't trip this time. Interesting. I'll change that set point again and see what happens next time. We'll try it more than once. Okay, the current draw dropped, so I'm thinking the compressor stopped. Now I'll go switch that setting again to run to continuous run. Alright, the dehumidifier's on non-stop run, so we'll see, just a matter of seconds or maybe a minute and the compressor will start and we'll see 5 amps here again. And hopefully it won't trip. The arc fault won't trip. Oh, there it is, up to 5 amps. Something came on, the load increased. And the only load on that circuit that can do that is the dehumidifier. There's a couple lights downstream, but they're not changing voltage, or they're not changing current. So I'll do this test one more time and then we'll say that this receptacle here that it's plugged into, right here, the one I just worked on when I was installing this wall, we'll say this one's good, and then we'll move downstream to the original one that the dehumidifier was plugged into again and run this same test there a couple times, maybe 3, if it especially if it trips it. Oh, come on, you. When it beeps like that, that means it's about to shut down. Pretty annoying. That was the third test, so now I'm just waiting for the compressor to stop. We'll see right there 1.68 amps. So now I'm going to stop the dehumidifier and move the cord. And just to be fair, I'll leave it on the same extension cord and plug this in over here. And action. Okay, now I'll go change it down to run continuous. Oh ho ho! As soon as it tried to come up, it tripped. This thing's beeping again, I guess. Let me reset that, turn it all the way off, turn it back on. Down to 1.69 amps. We'll see when that compressor comes back on if that trips. It's already on non-stop, but the compressor's obviously not on because we're not pulling 5 amps yet. I also don't like how dim this LED display is on these. I'll tell you, I might not buy this again. There's a few things about it that bug me. I bought it because I needed an amp clamp in the range that I would be using at home. This is the Klein Tools CL390. Seems like a nice enough meter, but there's a couple little things about it that bug me. This is still at 1.68 or 1.67 amps. Oh, you could see the current start to come up, and then it tripped. There's definitely a problem at that receptacle. I'll run this test one more time. Reset the breaker by turning it all the way off, and then back on. We're back at 1.69 amps, so the compressor's not running. The dehumidifier is still set to non-stop run, but obviously with the current at only 1.7, the compressor hasn't started back up yet. So we'll just give it a couple minutes here and see if it comes back up. Oh, you're kidding me, man. That's ridiculous. Oh, there it was. You could see the amperage spiked and then it dropped out. So I really do think the problem is in that receptacle down there. I'm going to have to pull this whole shelf unit out of the way enough so I can get behind it and work. These are back wired. When the electrical manufacturers designed backstab receptacles and the NEC permitted them to be used, they were facilitating electrical connection problems to be installed into the wiring of untold thousands or millions of new homes. Then, after these faulty connections probably caused a large number of fires, they invented and required arc fault circuit interrupters to be installed in every living space of our homes. The NEC requires AFCIs to be installed in living rooms, bedrooms, closets, hallways, kitchens, dining rooms, bathrooms, sunrooms, family rooms, utility rooms, and garages. They have to be in every habitable space in the home. If you search the subject online, the majority of comments from electricians are complaints about how bad AFCIs are. Most commenters blame AFCI trips on false trips, as if the AFCI devices are too sensitive or subject to trips from non-arcing electrical interference. It seems like people just hate them. My thoughts are conflicted. On the one hand, if we didn't backwire, we'd have a lot fewer problems. On the other, arc faults occur when a cord wears out because someone's been walking on it with it hidden under a rug, or where old insulation and cracks in old wiring start to spark. And that's where fires start. So they can be a lifesaver. And the data suggests they've prevented numerous fires. Since I'm stuck with a house full of backstabbed receptacles, I want AFCI circuit breakers in my panel. But are they reliable? Notice that 95% of my new AFCI breakers have never tripped, and that the only real problem is with a circuit in the cellar where it's been subjected to greater temperature changes and more humidity over the past 30 years than the living space circuits, which aren't showing any problems. So I have to ask, did they do any troubleshooting before condemning their tripping AFCI devices? Or are they just assuming these are false trips? What I'm learning and hopefully presenting in this video are methods of troubleshooting AFCI trips. I was thinking it would be a good idea for the electrical trade meter manufacturers to make a plug-in circuit analyzer that would detect the tiniest of arcs on a circuit. That might be helpful, and it doesn't appear anyone makes such a tester. I'd probably buy one. But it occurs to me that an AFCI does the same job, and they've been under development and refinement for probably over 20 years. So I don't think it's wise to blame them right off the bat. If an AFCI device is tripping, it's best to assume there's something wrong on the circuit and make an earnest effort of troubleshooting the problem. The AFCI device is your test instrument. While there's the possibility of a bad apple, for the most part, they can be relied on. It was a mistake not to go ahead and install a new spec grade receptacle right now. Okay, 2 amber lights are on. That means it's wired correctly. I'm going to hit the test button on the ground fault. It tripped out. So everything seems to be in order there. Plug this back in. So now the same 2 lights that were on before are on now. I've got 1.65 amps. And the dehumidifier is running, but I don't think the compressor is running on it yet. So we'll see what happens when that kicks on. Oh, it kicked on and we have 5 amps going. And it didn't trip. Interesting. So let me go change the settings so the compressor will shut off. Oh, there it dropped out. Down to 1.7 amps again, 1.69. 1.79 now, 1.80, let's see, 84, 85. 1.85. I just added the air purifier back onto the loads here. I plugged it back in. So now we're running 1.9 amps. And when that compressor kicks back on the dehumidifier, it should come up to 5. Or maybe closer to 6 now. 5.5 or so. Ooh, and it tripped when it came on. So now I'm wondering if the dehumidifier is the problem, but it wasn't the problem over here at this receptacle. I'm going to have to rerun my testing over on this receptacle that's closest to the breaker here again, just to make sure everything's good there. Okay, I moved that cord over. I'll reset it. Let's see what happens when that compressor kicks on. Oh, and nothing. We're running 5 amps and it didn't trip. That's with the compressor plugged in over here, the dehumidifier plugged in over here. Okay, I shut it off. We're down to 1.3 amps. Going to move it back over there. Whoa. As soon as I started the dehumidifier over there, it tripped. Okay, I'll reset this. Try again. I unplugged that air purifier down the line. So the dehumidifier just powered back up fine, 1.69 amps. And there it is. Tripped out again over at that location. But it doesn't trip out over here. I'm going to have to test that a few more times before I'm really convinced that's the case. Okay, I just redid the receptacle over here that was closest to the breaker. I actually replaced the receptacle. It makes no sense, but a new receptacle is going to eliminate any possibility of corrosion or something in there causing a problem. So now I'll go start the dehumidifier. .72, the dehumidifier is running. Those two LED lights down there should be on, and I'll go check and make sure that the air purifier is running. There's actually a little indicator on there that lights up and says non-stop. Oh, and it looks like it's already on. Okay, well, I wasn't having the problem with this receptacle that's closest to me here. I'm going to shut down the dehumidifier, move its cord back over to that other receptacle which was its original receptacle. So I'll plug it in there, start it up, and we'll see what happens. Okay, now I'm going to start up the dehumidifier. I went through 3 startup cycles on the dehumidifier, and there were no trips. So it appeared replacing receptacle number 1 fixed the problem with receptacle number 2, even though there wasn't an obvious reason why that would be. I guess that the receptacles might be faulty somehow. Maybe. At that point I plugged the freezers back in and... Remember, unplugging the freezers allowed the breaker to be reset the first time it faulted after wiring in the new breaker. Well, now with the freezers plugged in, there's a 100% fault again. So there's a new receptacle over by the utility sink. I added this when I added the sub panel in the garage. And this is both AFCI and GFCI protected. So I plugged both of the freezers in there on extension cords, and this will not only keep my freezers running overnight, but it'll prove that they're not tripping an AFCI or GFCI circuit. That way I'll know that the appliances aren't causing the problem. So I ran cords over to the freezers. Both freezers are plugged into this receptacle, which is normally where the sump pump is plugged. But I chose to do this receptacle for the freezers because one, it's already on an arc fault ground fault breaker, and two, believe it or not, this receptacle down here is tied into the bedroom circuit upstairs, up above here, and all the lights on this end of the house all the way up to the kitchen. So if one of those lights isn't working because it tripped, it'll get our attention. And then we'll come down here and check the circuit breaker, see if it tripped. I don't think that the two freezers are causing an arc fault, but this is how I'm going to find out. So I'm going to plug it in here, which is an old circuit from here. It's still good. It's ground fault protected, but it's not AFCI. I'm going to plug everything else in on that circuit that appears to be giving me trouble right here. Everything except for the dehumidifier, and see how it goes. I've had enough of this for one day. So I replaced that receptacle with a brand new one. I replaced that receptacle with a brand new one. I replaced that receptacle with a brand new one. I replaced that receptacle with a brand new one. And I replaced that receptacle with a brand new one. That's the one that has always had the dehumidifier plugged into it. And I replaced that receptacle with a brand new one. These are high quality receptacles. They're not the cheap stuff. And the wires are all terminated by wrapping them around the screw terminations, and tightening them down. Right now the dehumidifier is plugged in there and it's running. The light over the benches is turned on. I'm going to leave it on all day. The air purifier is on, and the light above the table here. I'm going to leave those on all day. Freezer 1 is on. Freezer 2 is on. You can barely see that green light on there, but it's on. And on this receptacle down here, where the bigger freezer is plugged in, I plugged in this 1200 watt heater. It's blasting heat out at me right now. So this is the stress test for the whole circuit. I've got that 1200 watts, plus the two freezers, plus the two LED shop lights, plus the air purifier running, and the dehumidifier. The other day this circuit breaker wouldn't stay on without faulting for more than 2 or 3 hours. So I'm going to leave all those loads on all day, and as long as that breaker doesn't trip, I'll trust it enough to leave it on all night, including the freezers. Plug all the appliances on the faulting circuit into another AFCI circuit that isn't faulting, being careful not to overload the test circuit. If the test circuit doesn't trip like the problem circuit is tripping, it probably isn't the appliances. I should have done this on day 1. Look for backwired receptacles. They're a known point of failure. I think I had several backwired receptacles that were failing from one end of that circuit to the other. Don't hesitate to replace every old receptacle on the circuit with new, spec-grade, side-wired receptacles. If you have backwired receptacles, don't spend time taking current readings like I did. Just replace them all. Don't cheap out on electrical repairs. I got a box of 10 Hubble CR20 almond tamper-resistant receptacles on eBay for $21 and change, all in. That's $2.10 per spec-grade receptacle. And they're only side-wired, so nobody's going to get lazy and backstab them. You can put multiple 15 amp receptacles on a 20 amp circuit, but don't if you don't have to. If there's only one receptacle on a 20 amp circuit, it must be a 20 amp rated receptacle. And don't ever put 20 amp receptacles on a 15 amp circuit. New receptacles should be tamper resistant to protect toddlers from curiosity. Any other loose connection could be a point of failure as well. Look for loose screws or bad or overheated splices in junction boxes. Also check the circuit for appliances or fixtures with worn or frayed wires. Extension cords running under carpeting have been known to wear out and start fires. Hopefully before that happens, your AFCI circuit breaker will trip and save the day. I've read comments to the effect that a wire staple was driven so hard it pinched the insulation and caused arc faulting. If all else fails, you could check for that as well. Non-metallic cable staples aren't supposed to be tight. The cable shouldn't be crushed. It should be free to move a little bit under the staple. If you don't like using them, use the plastic ones. These are easier to drive and more idiot-proof. That's why I use them. All of the receptacle circuits in my house happen to be daisy-chained. Consequently, the power flowing down the line passes through each of the receptacle's terminations, on down to the next receptacle. Wire nutting the conductors in the box together with a pigtail terminating each receptacle to the circuit will result in fewer problems. But if the pigtails backstab the receptacles, there can still be arc faults. When the wiring of a receptacle is daisy-chained, the current comes through one cable, passes through the receptacle through this termination plate, and then back out the other line. So all of the current passing through here to the receptacles that are downstream from it passes through the receptacle body itself. So even if there's no load on this receptacle, there's current passing through it, and it could be warming up. But when you do the pigtail wiring like this, the current comes through one cable and goes out the other cable, and they're terminated together with a wire nut. But then off that wire nut there's also a pigtail that terminates to the receptacle, and in this case it's under the screws like it should be. That way, let's say this is the first receptacle in line, and there's 7 other receptacles down the line like I have, and they're all loaded. You're going to have all that current passing through the conductor here, through the splice, and then back out on down the line. So none of that current is going to hit this receptacle. The only way this receptacle gets current is if there's a load plugged into it. In terms of reducing arc faults, if there's no load on here, it's not going to arc fault because you have a good termination here, and the current just passes through that termination, assuming that termination's good. And it's certainly better than any backstab termination. Thank you for watching. Please take a moment to like and subscribe.